All right, let's have a look at 1F. It says, during a cycle ride in the distance s kilometers of a cyclist from a fixed point on his ride is modeled by the function blah. It's quite a lengthy function, it's quite big. Okay, where t is the time in hours, not seconds, hours, since the cyclist passed the point, the fixed point, how far will the cyclist be from the fixed point when he reaches his minimum speed? So in that case, it looks like he's decreasing his speed. So he's starting here, he's going along, yeah, and this is going to call this point P. I'll call it a fixed point, I'll call it point P. It's going along, he's decreasing his speed. Right now, we want to find out, this. Let's say this is the minimum here. That's when acceleration must be equal to 0. We don't know what the velocity will be, but we don't really care. We just want to find out the time when the acceleration is 0. So that's what we want to find out here. Time question mark. Time here we'll say is 0. We don't know the velocity, nor do we even need to know the velocity. We just want to find, but we are going to find the distance here, and s is equal to question mark. So that's what we're going to do. So first of all, we've got the distance equation. We've got to turn that into an acceleration equation, which means differentiating twice. First of all, to turn it into velocity, and then differentiate velocity to turn it into acceleration. And then make acceleration equal to 0, and then solve for t. Once we find acceleration equal to 0, solve for t. Let's do that now. So I've got s bracket t is equal to 0.1875 t cubed minus 2.25 t squared plus 21t plus 0.5. I'm running into the other numbers there. That's not very good. I think I will just get rid of that because that would be quite distracting, I think. If someone just looked at the PDF of this and goes, well, how did you do that? So plus 0.5, and I'll put here s equals question mark. We don't know what s is. All right. So let's go ahead now, and the first thing we're going to do is differentiate it to find velocity. So v is equal to the differential of this, is equal to the differential of s with respect to time, and that is equal to, well, 3 times this. I'll just go ahead and do that now. So 0.1875 times 3 is, it's going to be 0.5625 t squared minus, well, I've got 2.25 squared, well, 2 times that's going to be 4.5 t plus 21. So that's going to be my velocity. Therefore, acceleration is equal to the differentiation of velocity with respect to time, which is equal to, well, 2 times this, let's go that, points, well, we got 5625, 0.5625 times 2 is equal to 1.125. That's 1.125 t minus 4.5. So there it is. There's our acceleration. Now we're going to make it equal to 0 because we want to find when the acceleration has become 0. Yeah, the acceleration is no longer accelerating, and we want to find, so it's now a constant velocity. So let's see what that's going to be. So we've got 1.125 t minus 4.5. I'm going to add 4.5 to both sides. There it is, plus 4.5. And I'm going to make t the subject. So I've got 1.125 t is equal to 4.5. Dividing both sides by 1.125. There it is. And I've got t. T now is equal to, and this is in hours, so I've got 4.5. 4.5 divided by 1.125 is equal to 4. Fantastic. So 4, and that's going to be hours, yeah, 4 hours. Now, of course, that is the time we are at this point here. This is going to be 4, so I'll put a 4 here. That's 4 hours. Here it is. We want to find out s. We want to find out how far it's traveled in that 4 hours. So to do that, we take the original equation and we populate this with a 4 every time we see a t. Here we go. So it's going to be s of 4 is equal to 0.1875 4 cubed. Oops, that's meant to be a cubed. There it is. Minus 2.25 t cubed, which is again 4 squared, sorry, not cubed, plus 21 times 4 plus 0.5. Real mouthful. Let's pop this, plonk it straight in on the calculator and see where we go. So here it is. It's going to be 0.1875 to the times, let's see, what's the best way? 4 to the power of 3. I'll just do it like that, yeah? And I'll go minus, that's 12, minus 2.25 times 4, that's going to be squared, equals negative 24. I'm going to go plus 21 times 4 plus 21 times 4 plus 0.5 equals. And I've got 60.5. So S4, should I say S4? Yeah, S of 4, that means the distance from 4 hours is going to be 60, we'll make it 60.5, and these are going to have to be kilometers or kilometers. Yeah, let's have a look. Blah, 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 blah. Yeah, it should be, because he's not going to ride for 4 hours and go 60.5 meters, yeah? He's going to fall off his bike, or she's going to fall off her bike way before there. So it must be, the answer must be 60.5, presumably kilometers. Oh, it does say kilometers. There it is. I thought I saw that. All right, so there it is. And that's how I'd go ahead and do that. You do need, I'd say, a context statement now. And you want to probably say something like, therefore, after 4 hours of cycling, the rider or cyclist will have covered a distance of 60.5 kilometers. And I would just say that. Let's write that point there, yeah? So S is, and now we can write it in here as well. Here it goes. Let's put it in. That's 4 hours, and this is 60.5. This is km, kilometers. All right. Hopefully that makes sense. Yeah, let me know.